Wheelover point is the specific point along the planned track where the helm must be executed to alter the ship's course to the next intended direction. The purpose of wheelover point is to ensure that the ship begins its turn at the right moment to achieve the desired new course without overshooting or undershooting the target. There are factors to be considered to determine the wheelover point. Those are the ship's speed, turning radius, rate of turn, and the angle of the intended course change. This might be easy if you are using an ECDIS in making a passage plan, but in today's video, I will show you how to determine the wheelover point manually. Assuming that this is your planned route. When a beam of Corcura point, the ship will alter course 050 degrees, with an approaching course of 350 degrees true. You've been advised by the captain to move the planned track closer to a lighthouse, and maintain a distance of 1 nautical mile from the lighthouse, while the ship is turning to the next course, then determine the wheelover point. The ship's length overall is 280 meters, with an average speed of 12 knots. This video shows 3 different methods on how to determine the wheelover point. The first method is to plot an arc or a circle where the lighthouse is at the center with a radius of 1 nautical mile. The actual position of the lighthouse is marked with a small circle at the base of the symbol. Use the latitude scale to measure the distance. As we know, 1 minute of an arc in the latitude scale is equal to 1 nautical mile. This latitude scale may differ from the actual chart, it is just made for the purpose of this video. This arc will be the track to be followed by the ship when altering course from 350 degrees to 050 degrees true, in order to maintain a 1 nautical mile distance while turning to the next course. We will now transfer the previously planned route along the arc. Both tracks should be touching the edge of the drawn arc. We have now a clear view of where the ship starts to turn, and to where it ends, but we need to determine the exact point. Draw a line from the lighthouse. This line should be perpendicular to the planned track. Do this on both tracks. This point where the perpendicular line intersects with the planned track is the turning point or transfer point. This point along the planned track is where the ship starts to respond from the executed helm and physically begins to turn. This point is not a wheelover point. On the other side, where the perpendicular line intersects with the planned track, is the point where the ship ends its turn and continues to its new course. The wheelover point can be found about a ship's length before the turning point. So if the ship's length is 280 meters, we need to convert it into a nautical mile so that we can use the latitude scale to measure 280 meters before the turning point. To convert it, 280 divided by 1852. We divide it by 1852 because 1 nautical mile is equal to 1852 meters. The ship's length in nautical mile is 0.151. Use the latitude scale to measure 0.151. This distance is 0.151 as shown on the scale. Measure the distance from the turning point along the planned track. This point is now our wheelover point. In this scenario, when we reach the wheelover point, we will execute helm to starboard. For bigger ships, it takes time for a rudder to react before the ship will start to turn. So we give an allowance of about a ship length. This method serves only as a guide. If you are on board, kindly refer to the company's Safety Management System or SMS manual on how to determine the wheelover point. How about if there is no reference point? How can we determine our wheelover point? This is the second method I will discuss in this video on how to determine the wheelover point. I will use the same length overall, speed, radius, and the planned track on the same spot, so that we can compare this later on from the first method. First, draw parallel index lines on both tracks. These lines should be in the inner part of the turn. The distance should be the chosen radius, In this scenario, our radius is 1 nautical mile. For a smaller ship, you can use a smaller radius. For a much bigger ship, you can use a radius greater than 1 mile. Kindly check the maneuvering characteristics of your ship on board, including the turning radius. Once the parallel lines are drawn, the intersection of these lines serves as your reference point, just like a lighthouse in the previous method. If we draw an arc or a circle with 1 nautical mile radius, where the intersection of the parallel index lines will be at the center, this is what it looks like. But I will not use this arc in this method, assuming that you do not have a compass divider on hand, so let us take it out. Next we will determine the turning point. Draw a perpendicular line on the plan track, intersecting the assumed reference point, which is the intersection of the two parallel index lines. Do this on both tracks. This point where the perpendicular line intersects with the initial track is the turning point. This is the point where the ship starts to turn if the helm is executed at the wheel over point. On the other side where the perpendicular line intersects at the plan track, is the point where the ship ends her turn, and proceeds to her new course. The distance from this point to this point is called reaction distance. The wheel over point can be found about a ship's length before the turning point. The ship's length in nautical mile is 0.151. So measure 0.151 nautical mile from the turning point, going backward along the initial planned track. This point will be our wheel over point. Upon reaching this point, execute helm to starboard. The ship will start to turn when she arrives at the turning point. Let us compare this method to the first method I have previously discussed. The two parallel index lines intersect at the lighthouse position, which serves as our reference point in the second method. The turning point is at the same spot as with the previous method, so as with the wheel over point. So whether we have a fixed reference point or none, we can still determine our wheel over point manually based on our preferred radius using the two parallel index lines. But kindly check the pilot card on board for the maneuvering characteristics of your ship, so that you can choose the desired radius during the course alteration. The third method is more on calculation. This method might be useful if you've been asked by some port authorities. You can discuss it with him, even on a piece of paper. I will use the same given from the previous method, with the same plan track, so that we can compare it with the previous method. First, we need to find the difference between the initial and final course. The final course is 050 degrees, minus the initial course which is 350 degrees, the course difference is 060 degrees. Before you can subtract these two, add 360 degrees to 050 degrees. So we have now 410 minus 350, the difference is 060. Next we will find the ship's rate of turn. The formula is ship speed, divided by radius. The given speed is 12 knots, but remember that when the ship turns, the speed reduces. We will assume that during the turn, the ship's average speed is 10 knots, divided by the radius which is 1 nautical mile. The rate of turn is 10 degrees per minute. Supposed to be, the rate of turn is 10 hours if we examine the existing units. To convert it into degrees per minute, multiply it by 180 divided by pi. The value of 180 divided by pi is 57.3. So we have 10 hours, times 57.3. To convert hours into minute, we will divide it by 60, since 1 hour is equal to 60 minutes. But usually, we do not do this procedure because if we look at the value of 57.3 and the divisor, which is 60, we can both cancel these values. The slight difference in the value, if we go through the procedure, is negligible when we are in the actual maneuvering. So just divide the ship's speed and the desired radius will give you a rate of turn, and the unit is in degrees per minute. I will make a separate video with a detailed explanation of how to determine a rate of turn. In this illustration, we just draw an arc assuming this is the ship's track during the turn. This calculation will lead to the exact location of the turning point. Next, we will determine how long it takes for a ship to turn from the turning point until the end of the turn, known as the time run. We will just divide the course difference and the rate of turn. So 60 divided by 10, the time run is 6 minutes, or 0.1 hour. We need to convert it into an hour because we need it later on. To convert into an hour, divide 6 minutes by 60, since in 1 hour is equal to 60 minutes. Next we will determine the distance traveled by the ship from the point she starts to turn, until the turn ends, known as distance run. Distance run is equal to ship speed, which is 12 miles per hour, times the time run, which is 0.1 hour. The distance run during the turn is 1.2 miles. Next we will determine the reaction distance. This distance is from the waypoint to the turning point. Reaction distance is equal to distance run, divided by 2, which is equal to 0.6 mile. Now measure 0.6 mile from waypoint to both sides of the track. This point now will be your turning point. And on the other side, this is the point where the turn ends. Use the given speed in calculating the distance run, which is 12 knots, because we will be measuring the distance along the waypoint, not along the turning circle. To determine the wheel over point, we will use the ship's length. From the turning point, measure 0.151 nautical mile going backward along the initial track. This point is the wheel over point. If we check the reaction distance in our previous method, it is also 0.6 nautical mile. These three methods give the same location of the wheel over point. That's all for now. I hope you find this video helpful. Thank you for watching. Bye.